to design a CRISPR experiment, if you want to change or edit a gene, you really just need to know the sequence of the gene that you wish to edit. And then you can design this RNA that you can then tether or attach to the enzyme that's called, in the initial specification of CRISPR, the nuclease is called Cas9. So you often hear people refer to CRISPR Cas9. And I have a wonderful video that I show in my talks from a Japanese group. They published this work a few years ago, showing under a very high, very powerful kind of atomic force microscopy is the name of the technique. But you see this blob, which is the Cas9 enzyme that cuts the DNA, sort of hovering over a piece of DNA that it has been programmed to identify and land on. And then at the appropriate moment, after all the sequence checks have been done, boom, you see the two ends of DNA literally just fall apart as the enzyme cuts them. And when the Nobel Committee last year said, we're awarding the Nobel Prize for the discovery of, quote unquote, the genetic scissors, it sounds like a kind of a crude analogy, but when you see this video, you think, yeah, holy cow, that really is like a scissors. So what can you do? You can do a couple of things. One is you can cut the DNA. The DNA strands that you've just broken will be repaired by the cell's own DNA repair machinery, but usually that will occur with one or two letters of DNA missing. So if you're looking to inactivate a gene, this is a very effective way of doing it. But you can also find ways to now correct the sequence. So maybe it is by providing a template, the correct gene sequence that you can provide, and that can potentially be stitched into these between these two severed strands. Or, as we can discuss in more detail, new forms of gene editing since the discovery of CRISPR in 2012 and 2013 have been published in the last few years that give us even more precision and now allow us to make literally pinpoint single base changes without even completely cutting the DNA. So this era of gene editing that has been sparked by the discovery of CRISPR is continuing to evolve as more new enzymes are found that are part of the CRISPR family, and new chemistries are developed based on CRISPR that give us even greater finesse in making certain DNA changes.